Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back. Student, as we started this design example and in lecture lecture L02 example 01 part A, in that lecture we have covered some portion of this example. Then in lecture 02 example 01 in part B, we covered this case 1 of this example, and then in part C we started this case 2. So while in L02 example 01C3 we started C1, C2, C3. In C1 we covered direct design method, in C2 we covered the tabular method, and in C3 we covered the graphical method to find the area of steel, right? We see in C3 lecture 02 example 01C3 we use this graph, right? We choose a point right here by using we choose a point right here, and because we know the value of mu divided by bd, and we draw a straight line right here in this direction to the right, and we choose the graph as we know about fy because we know this value, and once it coincides with this graph we draw a line just down here, and we find out the required steel area, which is here rho equals to 0.01025, and we find out our required area of steel, and for that we choose 6 number 7 or at number 6 bar. In present lecture which is L02 example 01C4, this is the last method, and the method is trial and error method, right? So in this example, in this part which is C4, we will cover the trial and error method to find the area of steel. We know all about the data, we have already found this, and we will use the trial and error method. So let's start. Trial number 1. We have to assume the A value, right? Most of the time the A value which will be assumed is 0.2d, but we can choose the A value ranging from d over 3 to d over 4. So let's say our A value is d by 3. So we know about d, that is 27, and if we divide 27 by 3 we got 9 inches, right? So my A value is 9 inches. So my area of steel, we know about this equation, which is a well-known equation. I have derived this equation in my lecture 01, 09 Fy into d minus A over 2. Now we just plug this A value right here, and the rest of the value we know it. Let me plug the value 352.4 times 12, right? We have to convert from kf feet to kf inches. 0.9 into 60 into d, that is 27, minus 9 divided by 2. If we use your calculator, we got the value 3.48 square inches, right? This is my trial number 1. Now we will check the assume A value. Let's say this is trial number 2. Now we will calculate the A value from by using this area of steel, which is area of steel times Fy divided by 0.85 Fc prime into B. We know all values. A is this much, 3.48, Fy is 60, Fc prime 3 ksi, and B is 12 inches. If you use your calculator, we got 6.82. So noting down here that A value get reduced from 9 to 6.82. So the area of steel value will be changed, and it will be lesser down. Again we will use the mu 0.9 Fy into d minus A over 2. This time we will use the A value is 6.82. If we use your calculator, we got the value from this is 3.32 square inches. Now we again revise. Now let's say we will using trial number 3. So trial number 3, we revise the A value. So A value is area of steel times Fy divided by 0.85 Fc prime into B. If we use this value, 3.32 times 60 divided by 0.85 multiply by 3 multiply by 12, we got the value of 6.50, and this time we can see a clear difference that this value is closing to the 6.82 inches. Now we will use the we will recalculate area of steel from mu divided by 0.85 0.9 Fy into D minus A over 2, and this time we will use this A, this one. So this time we got the value of 3.29 square inches, and we can clearly see that this time the value is close to the previously calculated value 3.32, right? If we revise and use, let's say we are using trial number 4, so this value will be coincide, right? Let's say A value is area of steel times Fy divided by 0.85 Fc prime into B. This time we will plug this value. We got the value of 6.45. See, this value is closing to the previously calculated value, so that why this time area of steel will be close to the previously calculated value. This time we will use mu 0.9 Fy into D minus A over 2, and again this time you will be surprised that this value is 3.29 so square inches. Now this is the required area of steel value, right? This is the required area of steel, and if you people remember, this is the exact value, right? This is the exact value, because trial and error method gave us the exact value. And if you people remember, in the first method, which we will use the direct equation 0.85 Fc prime divided by Fy into B into D minus D square minus mu divided by 0.3825 Fc prime into B. This equation also gives us 3.29 square inches area. So this 3.29 square inches inch square is the exact amount of the area of steel, right? And if I show you the previous method, the graphical method gives us the same value, that is 3.31. The tabular method gives us the same value, that is 3.3, because this row is same. And if we check the direct method, right? So in direct method, this equation gives us the value of 3.31 square inches, while using the equation, right, this equation, this will give us the value of we can see clearly 3.29. So this is the exact value, 3.29 square inches, right? And for this area, number 7 bar or 8 number 6 bar is sufficient, right? Is sufficient, and it will give us this amount of area. This arrangement gives us 3.52 and this arrangement gives us 3.60 square inches, right? This ends up this trial and error method. In next part, which is L02 example 01 part D. So in that part you will see the detailing, that how we will detail the bars in longitudinal and in cross section. So see you in that part. Thank you for watching.